to today's class. So today we'll be looking on binomial theorem. So to understand binomial theorem, what you have to understand first are what factorials are, what combinations are. Then after understanding that, we'll now understand what they call Pascal triangle, like the form of writing a kind of numbers in a triangular form, what's called Pascal triangle. And then we also understand what's called binomial expansion. Like now the formula for this is NCR ANBR. So I'll show you how to derive the formula and how to work with the formula. So you have to understand what factorials are and what combinations are. At first, you have to understand that this sign means factorials and this sign means combination. So the more we get to more problems, we understand to use it better. So let's start with factorials, which is denoted like this, like a kind of exclamation mark. So if I write 2 factorial, it simply means 2 multiplying 1. If I write 3 factorial, it simply means 3 multiplying 2 multiplying 1. If I write 4 factorial, this all means 4 multiplying 3 multiplying 2 multiplying 1, and so on and so forth. So you can see that the second number is this one subtracting 1, the third number is this one subtracting 2. So you can now generate a formula which says n factorial is n multiplying n minus 1 multiplying n minus 2 multiplying n minus 3, then and so on and so forth, multiplying 2 times 1. Yeah, so these are factorials, and they can give you even problems on factorials. Factorials and so that has some problems. So let's take like 2 examples, and then I believe you understand factorials. Then we'll treat combination, and you understand that, and then we'll do Pascal triangle. I believe you understand that also. Then go to the main thing right here. This 2n plus 1 and 2n minus 1. We are told to solve this. So this is solving the problem of factorials now. So you can do applying what I told you, n applying n factorial equals n multiplying n minus 1, n minus 2, and so on and so forth. Yeah, so now we can now apply the same thing, and this becomes n in this case. So it becomes 2n plus 1 as n multiplying, now this is becoming n also, 2n plus 1 minus 1, and this is also becoming, so 2n plus 1 minus 2. Then we can make 2n plus 1 minus 3 like this, and so on and so forth. And also make 2n minus 1 also like n in the same case, and say 2n minus 1 minus 1, 2n minus 1 minus 2, 2n minus 1 minus 3, so on and so forth, times 2 times 1. Yeah, so they can still become, this can now become plus 1 minus 1 give you 0, then all of this becomes 2n, right? Now plus 1 minus 2 becomes minus 1, then the whole of this gives us minus 1. Plus 1 minus 3 gives us minus 2, and the the whole of that becomes minus 2 also. So we can come here and do the same thing too. So also 2n minus 1 gives us minus 2. So here can become minus 2. Here is minus 1 minus 2 becomes minus 3. So here can also become minus 3. So minus 1 minus 3 can become minus 4 also. So here can become minus 4. So you see there, 10 minus 1 can cancel this. 10 minus 2 can cancel this. If there's another factor here saying 2n plus 1 to be 2n, this was 2n plus 1 minus 3. Yeah, this that became minus 2. If there's another factor here, it will be 2n plus 1 minus 4. What the whole of this means that there are numbers that are following this sequence inside this before it gets to 1. Yeah, there are numbers that are following the sequence here before it gets to 1. So that means there's also something like this also inside here, and even more also inside here. So you will notice that after this, the whole of this will begin to cut the whole of this. So if this was there, if this was also there, it will become 2n minus 3 also here, which will still cut this one here, which will still cut this one here. That means all of these denominators that will be forming will keep on cutting until it gets to this point. And what the only thing we would have left would be this. The final answer would be 2n plus 1 factorial over 2n minus 1 factorial plus 2n plus 1 multiplying 2n. These are just basic, very simple examples. I'm just trying to make you understand what factorials are. We are told to write all of these in factorials. Write the following in factorial. Those are the questions. Another very simple question. So write this in factorials. A 3 times 2 times 1 times 2 will be 3 factorial. And this now, B, which is 6 times 5 times 4. Writing it in factorial, there is no 3, there is no 2, there is no 1. It can become 6 times 5 times 4 times 3 times 2 times 1. And here can become 3 times 2 times 1. This would still cancel this. So this is how it was before it converted itself into this. So this can become 6 factorial over 3 factorial. So when you open up this, you will still get this. And then this 7 times 6 multiplying 3 times 2 times 1 over 2. Yeah. So now this can become this can become 7 times 6. Now there was something down that cut out this that made it become just 7 times 6, which is 5 times 4 times 3 times 2 times 1. Now multiplying another 3 times 2 times 1. Now that means the underneath now can be just from here to here, which is 5 times 4 times 3 times 2 times 1. Yeah. It actually was the thing that cut out this. Then times this 2. Then we can add up 3 times Okay, it can just be 2, the same 2 that was there, because there was nothing that was there, and 2 times 1 can always still be 1. Yeah. So we're trying to open everything. Then this is 7 times 6 times 5 times 4 times 3 times 2 times 1. This can be 7 factorial. And this can be 3 factorial over. Then this can become 5 factorial. And this is just 2 times 1, and this can also be 2 factorial. It can be your final answer. So you've converted this into factorial. When you open up this, you still come back and get this. Simple as that also. So now I believe by this you're going to understand what factorial are. And I'll take it to make you understand combinations. Now combination are denoted, okay, write it. Combination. They are denoted with letter C. Yeah, for combination. Yeah. So make you understand this, I can say n combination R. So n combination R simply means n factorial over n minus R factorial R factorial. This is what this simply means, and this is what you'll be applying to everything. Yeah, just as simple as that. What this C stands for is this here, and that's all. So we can still open up these ones and solve it to the final point of factorials. Just with your knowledge of factorials now, you can still say n factorial can be written as n multiplying n minus 1, right? But the point of that, just know this. The more we go for, I'll teach you what I actually want to teach you now. This is what you have to know now. So when it comes to combination, this is just the formula. When you see C, you just write n factorial over n minus this R factorial in bracket R factorial. Okay, so I think that's all you need to know about combinations. Like, this is what we'll be applying to binomial theorem. Then you can wait for our upcoming videos in which we'll teach you permutation and combination. We'll teach you how to turn word problem into this and solve. And our upcoming videos, you have to learn that. But this is all you need to know when it comes to binomial theorem. I don't think you need to know any more things besides this. So now, forthcoming video, you would see permutation and combination. Permutation is actually this, and combination is this in which it's written. So combination also means arrangement. So let's go to something else. So now we are going to Pascal triangle. So Pascal triangle now, it's just a simple way in which you write things in which you're going to apply it to. Okay, for example, when you see a plus b raised to power 2, yeah, we want to do it like this. A plus b also. This raised to power 2 means a plus b, a plus b. Then we want to expand and say a square, ab plus ab plus b square. Then it becomes a square plus 2ab plus b square, right? So you see ab cube, you want to say a square plus 2ab, which is this, multiplying a plus b to get a plus b cube. Sorry, you want to say this, so you have to now come back and start expanding and say a cube plus 2a square b plus ab square plus a square b plus 2ab square plus b cube. You want to say this, then you now come back and start summing up and say a cube plus this and this becomes 4a. Okay, sorry, this is a square. There is no other one. Okay, this is a square b, so this becomes 3a square b. Then this and this becomes 3ab square. Then this becomes bq. So look at the long process in which we actually use to get this. So what if you see a plus b raised to power 7? What would you do? So we are going to need Pascal triangles. So let's see how Pascal triangles work. Like, if I go on, let me tell you, there is no need for actually all of this anymore. Pascal triangle just helps to make your work very, very faster and very, very easy. So let me teach you Pascal triangle. Yeah, so Pascal triangle, just have to write this one on top, and then you write one here, and then you write one here. Yeah, just like this. So after you write one like this, like you want to draw a brick, then you're going to sum of this 2. When you sum of this 2, you get 2. After getting 2, you also write 1 here again and 1 here again. Then you sum of these ones, then you get 3. You sum of these ones, you get 3 also. Then you write 1 here again and 1 here again. Yeah, I'm actually making Pascal triangle. See, it's taking the form of a triangle. So when you sum of these 2 also, you get 4. Sum of these 2, you get 6. Sum of these 2, you get 4. Write 1 here and 1 here again. Yeah. So you keep on doing like that until, if you ask to do a plus b raised to power 2, you just simply say this equals a, you just write a square plus, now you just write this, write a square b raised to power 0. This front one will always be, you take this power and it will always be reducing, while this one will start from 0 and always be increasing. The first term written here is going to take this power here, and it will always be reducing. Why this will always be reducing? Why this will always be increasing? Sorry. So this is a square and b raised to power 0. Yeah, and this is 1 here. 1. So it becomes 1. How's this? We can now write 2 now. 2. This use Pascal triangle to get the coefficients of an expansion. So write 2 also. Then this now reduces to 1, and this increases to b raised to power 1 also, plus, now this is 1 also, then this is 1 multiplying b, now this will increase to 2, so it becomes a squared, anything raised to power 0 is 0, I taught you in indices, plus 2ab plus b squared. Yeah, simple as that. So also, when you see, you can keep on writing this until infinity, even till 100. We can also write 1, this will become 5, this will become 10, this will become 10, this will become 5, this will become more. You can keep on writing this till infinity. If you look at it, it looks like a triangle. Yeah, that's why it's called Pascal triangle. Yeah, that's why it's called Pascal triangle. So if you're given a plus b raised to power 5, yeah, you don't need to work, you just have to put 1, the first coefficient, then you write this, it's the first, then it carries the power 5, then this starts from 0, it becomes b raised to power 0, then you write plus, then you add up this coefficient again, 5, this one you add it up, yeah, then you write this, a, this now will reduce to 4, write this, we add up to 1, then you write again 10, then this becomes a, then this will reduce also to 3, then this will add up to 2, then you write this again 10, then this will reduce to square, this will add up to cube, then you also write 5, okay, 5, this will reduce to 1, this will add up to 4, then you write 1, a raised to power, now this would 1 minus 1 will give you 0, and b would increase to 5. So if you check very well, if you actually watch my indices video, you see you don't need to leave this like this. This becomes 1, and 1 multiplying this becomes this. And when applying any power, you don't need to add the 1 because everyone knows there's 1 there. So it's not an information. So there's plus here, so you won't also be needing this too. So it just become like this, yeah. So imagine opening this a plus b 5 times. How many hours will it take you before you get this? That's the use of binomial Pascal triangle. But we can actually yeah, you can actually get to see powers that are actually very much higher than 5, higher than 2. Like if you see powers raised to power 10, if you see powers raised to power 11, if you see powers raised to an higher figures than 7. So now how would you do it? If you see a plus b raised to power 12, even as big as this board is, it won't contain this triangle up to 12. Imagine writing 6 here, 15, 20, 15, 6, 1, then continue writing like that. Even your note won't be enough for you to write this up to 12 because this is 1, 2, 3, 4, 5. Yeah, this won't be enough for you to do that. So now, that's why they now brought out a better method which is known as the binomial, yeah, the use of combination. And that's what we'll get into now. Binomial theorem. So I'll take you on some examples. So before we go into the examples, I'd like you to know the general formula of binomial theorem, which is if you're given a plus b raised to power anything, let's call it n, raised to power n. The first thing you do is say, now the use of binomials and Pascal triangle are just to get the coefficients. We already know how to arrange the powers to make this first one reduce and make this other one increase. But the problem now is how to get the coefficients in front of the letters. That's the problem now. So I'll teach you this and you'll see how you use combination to get those coefficients without using Pascal triangle also. So whichever method you prefer, and like depending on how big this power is, that depends on what you're actually going to do. So this is a plus b raised to power n. So to get the first coefficient here, use this. You say n combination 1, then a raised to power n, b raised to power. Okay, it starts from 0, n combination 0, then b raised to power 0. Then it goes on like that, n combination 1, this turns into 1, and a becomes n minus 1, then b becomes 1, and becomes n combination 2, then a becomes n minus 2, then b becomes 2, yeah, and so on and so forth. So you can reduce this combination. What I taught you about combinations, that this means n factorial over n minus 0 factorial 0 factorial plus n factorial again, n minus 1 factorial 1 factorial plus n factorial. Okay, sorry, I didn't write these letters. So this is a raised to power n, b raised to power 0, yeah. Then this becomes n factorial over n minus 1 factorial 1 factorial, then adding up a n minus 1 b raised to power 1 plus n factorial n minus 2 factorial 2 factorial, then a n minus 2 b square, yeah, and so on and so forth. So you can still reduce this again and getting something else like what I taught you about combinations and factorials. Yeah, but you have to understand, since you're getting scared because of 0, whenever you see 0 factorial is equals 1, yeah, you have to know that 0 factorial is equals 1 any day, anytime. So we can still write out this further. To increase factorials, like I taught you minutes ago, it becomes n multiplying n minus 1, n minus 2, and so on and so forth. Then n minus 0 multiplying n minus 0 minus 1, and so on and so forth, 0 factorial. Yeah. Then, okay, let's keep this first. This, and this. So I don't know if the board is going to contain, but let's add it up though. And raised power 0 plus. Okay, this now becomes n also multiplying n minus 1, n minus 2 over. This one now becomes n minus 1, yeah, then n minus 1 minus 1, and so on and so forth, then 1 plus. This also becomes, okay, a n minus 1 raised by 1 plus. This also becomes n factorial n minus 1, n minus 2, okay, a n minus 2 b square over, yeah, and this is following this over n minus 2, n minus 3, then multiplying 2. So you can divide the same way I taught you dividing these factorials the same way. So it becomes n minus 1, okay, this becomes n minus 0, which becomes n. So this is n into n minus 1, n minus 2, a n b 0, then n minus 0 is just n, then n minus 0 minus 1 becomes n minus 1. Okay, you can see add up n minus 2. I told you these are a lot of numbers inside here, and 0 factorial is just 1. Yeah, all of these can cancel all of this. Yeah, plus this also becomes n into, okay, yeah, going to take it further. This can be minus 1 minus 1, then you can also, this is plus n into n minus 1, n minus 2 over n minus 1, n minus 2. I told you there are a lot of numbers inside here before you get here. So this is a n minus 1b over, okay, yeah, still part of this. Yeah, multiplying this. This is also multiplying 1, yeah, and this becomes plus n into n minus 1, n minus 2, yeah, and so on and so forth. Then a raised power n minus 2 and b squared over, this becomes n minus 2, n minus 3, and so on and so forth, multiplying 2. 2 factorial, not 2. Yeah, so there are a lot of numbers here, and in fact n minus 3 is also here too. Yeah, so the whole of this and this from n minus 2 can cancel because it starts with n minus 2, not n minus 1. You following? Yeah, so all this, the whole of this can cancel the whole of this, and the whole of everything inside can cancel the whole of everything inside. If you doubt, you can keep on opening n minus 1, n minus 3 and see for yourself. Then while this is cancelled, what we have left to be a, okay, let me write out this. So a plus b raised to power n will now become, only this will be minus a n plus it becomes n minus 1b plus n minus 1, then minus 2 and b square over 2 factorial. Yeah, if you were to write more, what would it be? What would it be if you were to write more? It would be n into n minus 1, right? Then we'll have another n minus 2 also, right? You can do it and confirm. And it will be an minus 3 b cube over, then here will be what? It will be 3 factorial. Yeah, and so on and so forth. So you can call this the general formula for binomial expansion. So if you are asked to expand anything using binomial expansion, or you just see that you can't expand that unless you apply binomial expansion, this is the general formula. This is what we'll be using to solve all of our problems. Yeah, so let's take a few problems. So let's take some basic examples. So I'll use the board and write out the examples. Okay, this question says we should expand that using Pascal triangle. And we should expand this using combinatorial effect. So let's see how we can apply those two things. So that first one says using Pascal triangle. You see it's all to the power 7. So we have to write out the Pascal triangle all to the power 7 and we take out those coefficients and we apply it, as simple as that. So let's go. This is 1, this will be 1, 1. This will be 2, 1 plus 1, 2, this becomes 1, 1. 1 plus 3 will give you 3, 3, you add 1, 1 here also. So this is 4, this is 6, this is 4, this is 1, you add 1 here also. This is 5, this is 10, this is 10, this is 5, this is 1, you add 1 here also. This is 6, this is 15, this is 20, this is 15, this is 6, this is 1, you add 1 here also. And this is 7, this is 6 plus 15 is 21, this is 35, this is 35, this is 21, this is 7, this is 1, this is 1 here also. So all we need is just this, because this is 1, 2, 3, 4, 5, 6, 7. Use coefficient 1, use this. Use coefficient 2, use this, use this, use this, use this, this and this. So we just need just this part. So I can write out this somewhere, or there's no point. But whenever you're expanding this, you shouldn't write it in your notes, or you're trying to solve for someone. Write that in your raw for somewhere, then just pick these coefficients. So let's expand that. So this is 1 plus x raised to the power 7 now becomes, write out this coefficient 1. Oh, okay, then this normal one that was there is 1 raised to the power 7, and this is x raised to the power 0, yeah, plus the other coefficient, which is 7. Now write out the first term, which is 6, then this adds up to 1, plus the next thing is 21. Okay, so this reduces to 7, this increases to 2. Yeah, the next coefficient is 35. Right here, 5, and okay, this is meant to reduce to 5, and this increases to 2. Now 1 also reduced to 4, and this increases to 3. Then also 35. Then 1 also reduces to 3, while x increases to 4. Then 21 also. Now 1 reduces to 2, x increases to 5. And then 7. Now 1 reduces to 1, then x increases to 6. Then plus this one now, then 1 reduces to 0, then x increases to 7. So can I write out the final answer above? So the final answer would be, okay, this n to the power 0 is 1, 1 raised to the power 7 is 1. 1 multiplying 1 is 1. So 1 plus x raised to the power 7 becomes, this becomes 1. Yeah, 1. And the next thing that follows it becomes plus 7x. Yeah, because this is 1, this is x, this is 7. Plus 21 x squared, then plus 35x cubed, yeah, plus 35 x raised to the power 4 plus 21 x raised to the power 5 plus 7x to the power 6 plus 1 raised to the power 0 is 1, then x raised to the power 7. Yeah, this is the expansion of that. So let's take the other example. So the other example now is using combinatorial effect. So it becomes 3 minus 2x raised to the power 4. Using combinatorial effects telling you are meant to use any combination something. So you can apply. I want to teach you a new formula, I should take it down somewhere. So the formula for solving this, I can tell you it is n combination r. Yeah, I told you at first though, this is what you always be applying. N combination r, and to get r is always r plus 1 is equals a term. Like r now is always the power, is equals term. Like we tell you second term, third term, or whatever. Yeah, you see how we apply it, you see, you learn. So let's start. So to get the first coefficient, we apply n combination r, like I taught you. And we can also go back to the last formula I taught you. Combination effects is doing it in a like binomial theorem way, so we can go back to the other formula I taught you. So there's no need of writing this. Write a plus b raised to the power n is equals a raised to the power n plus n into, okay, n a n b plus n into n minus 1 over 2 factorial, then a n b squared, and so on and so forth. You can apply this formula, then it can become 3 raised to the power n is 4 plus the n now becomes 4, then a becomes 3 raised to the power 4, yeah, then b becomes minus 2x plus n remains 4. 4 minus 1 is 3, then a is 3 raised to the power 4. Okay, okay, okay. This is n minus 1, this is n minus 2. Yeah, yeah. So this should be 3 and this should be 2. Yeah, 3 raised to the power 2 and minus 2x raised to the power 2. Yeah, plus. You can also have, since it's not finished, you can also have n into n minus 1 over, okay, let me write it somewhere, n into n minus 1, n minus 2 over 3 factorial, and whatever is this, plus n into n minus 1, n minus 2, n into n minus 1, n minus 2, n minus 3. over 4 factorial. You keep on writing that and writing that and writing that. When this is 3, this is 4 factorial. When this is n minus 4, this is 5 factorial. When this is n minus 5, this is 6 factorial, and so on and so forth. So now the next one becomes this, which remains 4 into n minus 1 is 4 minus 1, which is 3, and then sorry, over, this should be over 2 factorial, yeah. Then so n becomes 4 multiplying 4 minus 1, which is 3, then 4 minus 2, which is 2, then write this. A now becomes 3 raised to power, it will now be n minus 3, right? Yeah, n minus 3, which is 4 minus 3, which is 1. Oh, then b is minus 2x, then now it increases to 3, yeah, over 3 factorial, and write the last one, which is this, which is n is 4 into 4 minus 1, which is 3, and 4 minus 2, which is 2, yeah, then 4 minus 3, which is 1, yeah, and then we have a, which is 3. It was 1 here, now it will now be 0 because it's reducing. This was 2, this was 1, so it now be 3 raised to the power 0, okay. Then b now, which is minus 2x, it's actually increasing, so it raised to the power 4. So if you check well, you see a was raised to the power 4 here, then it's reduced to raised to the power 3 here, then this increased to 1. You see that? Then it reduced to raised to the power 2 here, then this also increased to 2. It reduced to raised to the power 1 here, and this increased to 3, and it's reduced to 0 here, and this became 4. So till this becomes 0, you don't stop. You keep on going and going and going until this a becomes 0. So this is over 4 factorial. Yeah, simple as that. So let's open up everything. So this becomes 3 times 3, 9, 9 times 3, 27, 27 multiplying 3 will be 81, plus this is 27 multiplying 4, this is 108. Yeah, 108 multiplying minus 2x, multiplying minus 2x, that becomes minus 216x squared, plus, okay, sorry, normal x. Yeah, so this is 4 times 3, 12. You can use your calculator also. 4 times 3, 12. Then 3 square is 9. 12 multiplying 9, that's 108. Then 108 multiplying 4, and that's minus 432x squared, all over 2. 2 factorial is 2 times 1, which is 2. Plus, now this is 4 times 3 times 2 times 1. Sorry, 4 times 2 times 3 multiplying 8. Okay. This is minus 2 times minus 2, so it should be positive 4. Yeah, for that other one. Why this is minus 2 multiply minus 2 multiply minus 2 is raised to the power 3. I taught you in indices. When you see a negative sign raised to an odd number, it becomes a negative sign. So this is 2 times 2, 4, 4 times 2, 8. Now it becomes negative. Negative, whatever you get. 576 over 3 times 2 times 1, 3 factorial, which is 6, plus, then this also becomes 4 times 3 times 2 times 1 times 2 times 2 4, 4 times 2 8, 8 times 2 16. This is our even number, so it becomes positive 16. So multiplying 16, that's 384 e power x power 4 over 4 times 3. This is 4 times 3 times 2 times 1. So opening this becomes 24. So now let's divide those things. So this remains 81. It remains 216x. So 432 dividing 2 becomes plus 216 raised to power x squared minus 576 dividing 6 becomes 96 x cubed plus 384 dividing 24 becomes 16x raised to power 4. Yeah, and that's your final answer. So you take 2 more exercises, and I believe with that you're meant to understand binomial theorem.